Hello everyone, welcome to my YouTube channel. I'm Sabina Aydınova. Today I will explain this task. Define the type of equation and write equations of characteristics. X squared uxx plus xy uyy is equal to 0. What does it mean? Firstly, equation of form ax y u of xx plus 2b xy uxy plus c of xy uyy plus f of x, y, u of x and u derivative of u respect to y is equal to 0 is called linear partial differential equation of the second order. And here a of xy, b of xy and c of xy are the given functions. In order to identify that which type of equation is this, we have to look at the principal part of this equation, and principal part of it is this part. Alright, and here if b squared minus ac is greater than 0, then such type of equation is hyperbolic. If in b squared minus ac is equal to 0, this is parabolic type. If b squared minus ac is less than 0, it means that this type of equation is elliptic. And in our case, here a is equal to x squared, b is equal to zero. There is no xy, uxy, and c is equal to xy. Then b squared minus ac is equal to 0 squared minus x squared times xy. It means that it is negative x cubed y. But we don't know that it is hyperbolic, elliptic or parabolic, because x can be any number, y can be any number, and we don't know that solution will be negative, positive, or will equal to 0. And in this case we have to look at all three cases: hyperbolic case, elliptic and parabolic type. Let's begin with hyperbolic type. And you know that in hyperbolic type, if b squared over ac is greater than 0, then it means that it is hyperbolic type of equation. Let's check this case. If x squared negative x cubed y is greater than 0, it means that it's hyperbolic. And it also means x cubed y is less than 0. And you know that you have to keep in mind that x have to be different from 0 and y also have to be different from 0. And this equation is hyperbolic at the points either x is greater than 0 and y is less than 0. And the second case, this equation will be parabolic at the points where x is less than 0 and y is greater than 0. How did I find it? Because for example, x greater than 0, for example, it can be 1, positive 1, and y can be negative 1. Then 1 cubed will be 1, and negative times negative 1, it will be negative 1, and negative 1 is truly less than 0. And either case, if x is less than 0, for example, x can be negative 1 and y is greater than 0, for example, y can be 1, and negative 1 cubed will be negative 1 times positive 1 will be negative 1. And this is also true that in this case x cubed times y will be less than 0, and it's gonna be hyperbolic type. And for example, I can show it in the graph. This is y-axis and this is x-axis at the points, and you have to know that this part, I mean where the points x is equal to 0 and y is equal to 0 are not our solutions, and where x is greater than 0 and y is less than 0, this is this part, and where x is less than 0 and y is greater than 0, this part, at this point, this equation will be hyperbolic type. But we can find characteristics of this equation. How can we find it? There is some formulas of it, and you can find these formulas by doing some calculations, but I will write them a given formula. First characteristics of the hyperbolic type equation is found by this formula: a dy minus b plus square root of b squared minus ac dx is equal to 0, and where a is equal to x squared dy minus 0 plus, you know that we found square root of b squared minus ac will be square root of negative x cubed y dx is equal to 0. It will be x squared dy minus square root of negative x cubed dx is equal to 0. Let's divide by x squared square root of y, then our solution will be dy over square root of y minus square root of negative x over x dx is equal to 0. And I can write that dy over square root of y minus square root of negative x over x squared dx is equal to 0. And I can write that dy over square root of y minus 1 over square root of negative x dx is equal to 0. Let's write that negative x is equal to z, then x is equal to negative z, then dx is equal to negative dz. Here, let's integrate both sides of it. It will be dz is equal to 0, and by the power of negative 1 over 2 plus 1 over 1/2 plus negative 1/2 plus 1 plus z to the power of 1/2 plus 1 over 1 negative 1 plus 2 plus 1 is equal to some constant c1, and it's equal to c. This is our first characteristics of equation, hyperbolic type of equation. And let's calculate this. Then it's going to be 2 square root of y plus 2 square root of negative x is equal to c. And yeah, that's our solution, because we found that y to the power of 1/2 over 1/2 plus z to the power of 1/2 over 1/2 is equal to c1, and this is equal to c. We write as negative x instead of z because we substitute it, and now we get back. This is our first characteristic of hyperbolic type equation. In order to find the second of it, we write this formula. In the first characteristics of hyperbolic type equation, I write this formula, and I'm right here another formula: a dy minus b minus square root of b squared minus ac dx is equal to 0. Then it is x squared dy plus square root of negative x cubed y dx is equal to 0, and solution of it will be square root of 2y minus 2 square root of negative x is equal to eta, and this is second characteristics of hyperbolic type equation. How did find it? Because here there is negative sign, sorry, here plus, then will be negative, yes. Now, how can we find the parabolic type of equation? Here, this is second case. I found hyperbolic type. Now it's time to find the parabolic type. In order to find that this is parabolic type, we have to write that b squared over ac is equal to 0, and this is or can be at the point x is equal to 0, or y can be equal to 0, and it will be in the graph like this, where the x or y is equal to 0, and this part show that this equation is the parabolic type. And there are also characteristics of parabolic type equation, and its formulas are like this: a dy minus b dx. You can find this formula that by some calculations, but I write the obtained formula, and here square root of x squared dy is equal to 0, and I write that x squared y is equal to c1, and it's equal to c. This is first characteristic. And how can we find the second characteristics of parabolic type of equation? In order to find it, I write this determinant in the first row, the derivative of c with respect to y, then derivative of c with respect to y, and derivative of eta with respect to x, derivative of y with derivative of eta with respect to y have to be different from 0. We can write anything in the place of eta, that this determinant have to be different from 0. Let's find cx. This will be derivative of x with respect to x, then it is 2xy, and derivative of c with respect to y will be x squared. Then I write them in the determinant: 2xy, x squared. For example, I write that eta is equal to x plus y. It is 1 determinant of it 2xy minus x squared, which is different from 0. Yeah. Now let's find the parabolic type of equation of it. Sorry, elliptic type of it. We found hyperbolic, parabolic. Now it's time to find elliptic type of it. B squared minus AC have to be less than 0. I mean, in our task it is negative x cubed y is less than 0, and x cubed y have to be greater than 0. Then this is true either at the point x is greater than 0 and y is greater than 0, and either x is less than 0 and y is less than 0. Let's show it in the graph. This is y-axis and this is x-axis. It is true at the point x is greater than 0 and y is greater than 0. I mean, x cannot be equal to 0 and y cannot be equal to 0. This is 0 and bound of it. This is not belong to our solution. And where x is less than 0 and y is less than 0. Of course, there are characteristics of elliptic type equation. Its formula, first characteristic of it is found by this formula: a dy minus b dx is less than 0, and it will be x squared dy will be equal to 0, and find that x squared y is equal to c1, it's equal to c. It is first characteristics, and cx is equal to 2xy, cy is equal to x squared, and this is real part of it, real characteristics. And second characteristics is found by this formula: ac or minus b squared dx is equal to 0, where x cubed y dx is equal to 0. Yeah, that's right. Integral square root of y x to the power of 3 over 2 dx is equal to 0, and let's integrate it. Then it's gonna be square root of y times x to the power of 3 over 2 plus 1, 3 over 2 plus 1 in the denominator is equal to c2, some constant, and it is equal to eta, and this is our second characteristics. Let's calculate it. Square root of y times x to the power of 5 over 2 over 5 2 is equal to c2 equal to eta, and here we find that square root of y times 2 times square root of x to the power of 4 times x over 5 is equal to c2 is equal to eta, and this is also that 2x squared to the power of x squared of xy over 5 is equal to c2, and this is equal to c and the second derivative. Solution of this task is in this form. I hope that you liked. Please hit the like button if you like this video. Thank you for watching this video until the end. You can share this video who are interested in mathematics. Thank you for watching.